Hey everyone, and welcome to This Explainer. Today we're going to fundamentally shift your mindset from, just writing lines of code to actually architecting true enterprise-grade resilience. We're tackling a really massive integration challenge today, specifically how to handle fire and forget data exactly like a principal architect would. Let's kick things off with a core philosophy from our source material. This is one of those insights that instantly separates the junior developers from the principal architects. It goes, I wouldn't start by thinking about account creation. I'd first think about reliability, data durability, and recovery because the sender is using a fire and forget pattern. That right there, that's the golden rule of system design. Your number one priority isn't the business logic, it's making absolutely sure the data actually survives. The second your system says, yep, I got it, you own that data entirely. So to achieve that level of operational excellence, we're going to follow a massive data payload through 6 crucial stages. We'll cover 1. The fire and forget challenge, 2. Persist first, process later, 3. Async execution and parsing, 4. Smart upserts and partial success, 5. Handling failures and retries, and finally, 6. Observability and governor limits.
Okay, Section 1, the fire and forget challenge.
I want you to imagine a giant delivery truck pulling up and just dumping an unbelievable volume of JSON messages right onto your digital front porch. We are talking 250,000 individual messages hitting your API at blinding speed. And it gets heavier, because inside every single one of those individual messages, you have exactly 2,000 account records packed in. If you do the math on that, it's a completely colossal amount of data flooding into your organization all at the exact same time. If your architecture isn't purposely built for this exact scenario, I promise you, your servers are going to completely buckle under the weight. Because here is the somewhat grim reality of the fire and forget pattern. The sender, they just speed away right after delivery. They aren't tracking a single thing. If you don't secure those digital packages immediately, that data is permanently gone. They are not going to resend failed records, mainly because they don't even know what succeeded in the first place. From the exact millisecond that data arrives, your system owns the processing entirely. Resilience simply has to be your absolute highest priority. Moving on to Section 2, persist first, process later. So the absolute biggest mistake you could possibly make right now is trying to loop through all 2,000 accounts synchronously. If you try to process and insert every single one of them while the external system is just sitting there waiting on the REST API connection, you're going to crash. You'll hit request timeouts, you'll max out CPU limits, or the client will just disconnect. Instead, you need to simply persist the raw payload exactly as it arrived and immediately return a 202 accepted status. Done. This brilliant little pivot is what we call durable messaging. By saving that raw payload immediately into a custom object, it means that even if your server completely crashes a literal second later, you've got a hard copy. Nothing is lost. The baton was safely passed, and now your system can take a breath and handle the actual processing at its own pace. Which brings us to Section 3, async execution and parsing. All right, now that the data is safely locked away, we can actually get to work processing it. To do this, we use an asynchronous engine. We fire off a platform event to process that JSON in the background, meaning no external user is left hanging waiting for a response. By handing this heavy lifting over to a queueable or batchapex process, we're completely decoupling the receipt of the data from the processing of the data. That protects your system's performance and keeps you far away from those nasty timeout errors. Now, while this background processing is happening, we are rigorously validating these records. The rule here is we never, ever let one single bad record stop 1,999 perfectly good ones from going through. So we parse the payload into data transfer objects, we check for required fields, we verify that the emails are actually formatted like emails, and we filter out the garbage. Essentially, we're sorting the records into a valid pile and an invalid pile before we ever even touch the database. It's all about making sure we don't waste precious system resources on guaranteed failures. Section 4, smart upserts and partial success. When it's finally time to commit the data, we use a very specific command, the database upsert command, and we make sure that little false parameter is turned on. That completely changes the game for how failures are handled. Unlike a standard insert command that either totally succeeds or totally fails as one giant batch, that tiny false flag is literally the secret to enterprise resilience. It perfectly illustrates the concept of partial success.
Let's say 5 records out of the batch have bad data. Well, with partial success, we still successfully commit the 1,995 good ones. We don't roll back the whole transaction. We just quietly log those 5 specific failures in a custom object so we can deal with them later. This keeps that massive data pipeline flowing smoothly instead of grinding the whole operation to a halt over a couple of typos. But as we're doing these inserts, a pretty major vulnerability pops up that we definitely have to protect against. Think about it. What happens if the external sending system glitches out and sends us customer 123 into completely different payloads? If you don't have protections in place, you just insert them both, instantly polluting your database with duplicates. Not good. So we protect the database by enforcing item potency. That's a fancy word, but it just guarantees that any duplicated data gracefully updates existing records rather than creating new ones. By keying off a unique external ID during our upsert, your system essentially becomes bulletproof against duplicate transmissions. Honestly, it doesn't matter if they send the same record once or 100 times. The end state in your database is going to remain perfectly accurate.
Let's look at Section 5, handling failures and retries. Okay, so what exactly do we do with those few records that inevitably fail? Well, for temporary hiccups, things like row locks or sudden network timeouts, we use an exponential back-off strategy. Basically, we space out our automatic retries to give the system some breathing room to recover. If a database row is locked, hammering it again every 10 seconds isn't going to help anybody. But trying again in 5 minutes, and then maybe 30 minutes, and then 2 hours, that allows the temporary congestion to just naturally clear up, zero human intervention required. However, you've got to carefully contrast those temporary issues with permanent failures. Permanent failures should never be automatically retried. Instead, they need to go straight to an exception queue for an actual human to review. Think about it. A malformed email address isn't going to magically fix itself on the 3rd try, right? An administrator actually needs to look at that, fix the source data, and then manually replay just those specific failed records. Finally, Section 6, observability and governor limits. Since we know the external system tracks absolutely nothing, it's entirely on us to build a comprehensive operations dashboard. And because we were smart and logged our raw payloads, our successes, and our specific failures earlier on, we can easily give the business a real-time, transparent view of the system's health. You'll know exactly what's pending, what's sitting in the retry queue, and what needs a manual fix. You aren't guessing anymore, you're operating with total clarity.
And hey, if these massive payload sizes really start threatening to breach our system's governor limits, we have options. We can pivot over to the Bulk API 2.0, or we can even offload the raw files to external cloud storage. A true architect always has a backup plan for scale. If 2,000 records per payload breaks our heap size, no problem. We negotiate the payload down to 500 records. Or we have the sender drop a raw file into AWS S3 or Azure, and they just send us a tiny reference link so we can go fetch it asynchronously. So as we wrap up this explainer, I want you to really ask yourself this question the next time you're facing a massive integration challenge. Are you just trying to get your code to compile so you can insert an account? Or are you designing a system for true durability, resilience, and operational visibility? When you build for fire and forget data using these exact principles, you ensure that no matter what chaos the external system throws your way, not a single piece of data is ever lost. Keep that architectural mindset strong, and I'll see you in the next explainer.